Okay, let's talk renewable energy. What's the first thing that pops into your head? Probably solar panels, right? Or maybe those huge wind turbines. But what if I told you the biggest player in the renewables game is actually something way older? Something that might even be in your backyard right now. Yep, today we're diving deep into bioenergy. And let me tell you, it's a powerhouse that's as crucial as it is controversial.
All right, just take a second and let this sink in. This is a real eye-opener. Back in 2019, bioenergy made up a whopping 12% of all the energy we use globally. Now get this, that's double, literally double what solar, wind, and hydro gave us combined. It's a staggering number, and it kind of forces us to hit the reset button on what we think we know about renewable energy.
So, you've got to be asking, what is this unsung giant, really? And how can it be both a potential savior for our climate and, at the same time, the source of so much heated debate? Well, that's what we're here for. Let's unpack this.
Okay, so first things first, what are we even talking about? Bioenergy, in simple terms, is just energy we get from biological stuff. You know, things that are or were alive. We're talking about a huge range of things, from crops like corn and sugarcane to wood chips, agricultural leftovers, and heck, even the food scraps from your kitchen. It's actually the oldest form of energy humans have ever used, and now, ironically, it's right at the heart of a super modern, super important debate.
You know, to really get a handle on where bioenergy is headed, we have to look at where it is right now. And for a massive chunk of the world's population, the reality is, well, it's summed up in this one number, 2.4 billion. That's not just a statistic. That's 2.4 billion people who, today, still rely on burning wood, dung, or charcoal, often in open fires or simple stoves, just to cook their food and heat their homes. And the hidden cost of this, it's just devastating. This isn't just some quaint, old-fashioned way of doing things. No, it's a full-blown public health crisis. We're talking about nearly 4 million people dying prematurely every single year from breathing in that indoor smoke. It's a tragedy that hits women and children the hardest. And on top of all that, you've got localized deforestation and land degradation. It's just so clear that we desperately need a better way.
Okay, so that's the grim reality of traditional bioenergy. But as we look to move beyond these really harmful practices, a completely different picture starts to emerge, a new promise. See, modern bioenergy isn't just about finding a cleaner replacement for a cooking fire. It's being positioned as a genuine cornerstone for hitting our global climate goals. And when we say it's a cornerstone, we mean we're going to need a lot more of it. Just look at these numbers. This isn't some small tweak. To stay on track for a 1.5-degree future, the scale-up required by 2050 is just massive. I mean, check out the bars for transport, for industry, for buildings. We're talking about something like a threefold increase in our sustainable biomass supply. That's a seriously huge undertaking.
So, you might be wondering, why the big push? Why bioenergy specifically? Well, it's because it has a special superpower. It can go where other renewables just can't, at least not easily. Think about it. How do you power a jumbo jet with solar panels or a massive container ship crossing the Pacific? And what about the intense heat needed for making steel or cement? Wind turbines aren't going to cut it. For these really tough sectors, biofuels and biomass are one of the very few viable options we have on the table right now.
And then there's the really wild part. The thing that sounds like science fiction but isn't. It's called BECCS. That stands for Bioenergy with Carbon Capture and Storage. Okay, stick with me here because this is kind of mind-blowing. Step 1, plants grow, and as they do, they naturally pull CO2 out of the air. Cool. Step 2, we use those plants to generate energy. Step 3, and this is the magic part, we capture the CO2 that's released during that process and we store it permanently deep underground. So what's the end result? We're not just aiming for zero emissions, we're creating negative emissions. We're actively cleaning up the atmosphere. Now that is a potential game changer.
Okay, that all sounds amazing, right? A solution for tough industries, a way to get negative emissions, but, and you knew there was a but coming, didn't you? This is a really, really big but. This powerful tool comes with a whole host of serious risks. This is where the story gets complicated.
So you're probably thinking, if it's so useful, if it's so critical for our climate goals, what's the catch? What's the problem here? Why all the controversy?
Well, it really all boils down to one simple fact. Bioenergy is a classic double-edged sword. On one side, you have all this incredible potential, creating jobs, helping restore degraded land, improving how we manage waste, giving people access to modern energy, all fantastic stuff. But on the other side of that sword, the potential downsides are just as stark.
We're talking about serious risks like deforestation, wiping out biodiversity, and sparking a direct conflict between growing fuel and growing food.
So let's drill down on some of those risks, because they're important. One of the biggest concepts to wrap your head around is something called carbon debt. Imagine it like this. You cut down a mature forest to plant fast-growing energy crops. In that moment, you've just released a huge amount of carbon that was stored in those old trees and soil. It's like taking out a massive carbon loan. Sure, your new crops will start absorbing CO2, but it could take decades or even centuries to repay that initial debt. And in the meantime, you've actually made climate change worse, not better.
And it's not just about carbon math. There are very real human costs to consider. The most famous one is the whole food versus fuel debate. It's a simple but powerful question. If we're using huge tracts of land to grow crops for our cars, what does that do to the price and availability of food for people? And what happens to the small farmers who might be pushed off their land to make way for these giant industrial-scale energy plantations?
So it all sounds pretty risky, right? But here's the most important takeaway from all this. None of these negative outcomes are inevitable. They're not guaranteed. They're huge challenges for sure, but they're challenges that can be managed. So the debate really shouldn't be, is bioenergy good or bad? Because it's not that simple. The real question is, can we be smart enough and careful enough to get it right?
Okay, so if we want to get it right, we first have to be honest about what's stopping us. And believe me, the roadblocks are pretty big. You've got policy uncertainty that scares off investors. You have different government departments like energy, agriculture, and environment that don't seem to talk to each other. And of course, there's the sheer cost of building all the new infrastructure. These are the major hurdles we have to clear.
But here's the good news. We're not flying blind. We actually have a blueprint for how to do this successfully. And it all comes down to one thing: smart governance. What does that look like? Well, for starters, it means our goals have to be about sustainability first, not just about producing a certain number of megawatts. It means forcing all the different players, energy folks, agriculture folks, forestry experts, to actually sit down and coordinate. And crucially, it means putting strong regulations and standards in place that connect our energy plans to our bigger goals, like the Sustainable Development Goals.
And a really crucial piece of that governance puzzle is certification. The easiest way to think about it is like an organic or a fair trade label, but for bioenergy. You have these independent groups, these watchdogs, who come in and verify that the biomass is being sourced responsibly. They check the whole supply chain, from the forest all the way to the fuel tank. It's absolutely essential for building trust and making sure we're actually doing good, not just claiming to.
So where does that leave us? I think it's this. Bioenergy isn't the simple hero or the clear-cut villain in our climate story. It's not one or the other. It's a tool, a really, really powerful tool, one that's both necessary and loaded with risk. And so the ultimate question, the one we have to answer, isn't really about the tool itself. It's about us. Are we wise enough? Are we coordinated enough to actually use it right?